All right. Maximum. This is 2nd of April, 2026. I did yesterday's problem. I just didn't record it because it was a bit. I'd already done it, so I was like, I don't do it. I don't have to record it again. Maximum amount of money a robot can earn, with an acceptance rate of 30%, which is a bit scary. But yeah, yesterday's problem was also about robots, robot collisions. So maybe this is the theme: robots. Oh, we're given a matrix. You're given an M by N grid. A robot starts in the top left corner and wants to reach the bottom right corner. Oh god, this sounds like the DP thing all over again. The grid contains a value coins ij in each cell. If coin ij is greater than 0, then the robot gains that many coins. If it's less than 0, the robot the robot encounters a robber and the robber steals that much. The robot has a special ability to neutralize robbers in at most 2 cells on its path. Right. Okay, and then figure out the robot's total coins can be negative. The robot can be in debt. Oh no. Return the maximum profit. Okay. Generally, whoops, sorry, it's the wrong side. Generally makes sense. 3418 POTD. So you're given an M by N grid. So input M by N grid. Robot starts top left. Destination is bottom right. Fair enough. So then you have this one, and then you have coins. So the goal is to grab as many coins as you can. Bearing in mind, you can only go down or right. You cannot go up or left. So you can't like backtrack your way and get more coins that way. Goal is to grab as many coins, which is positive values, as you can. Avoid negative values, right? The robbers. But bear in mind that you can neutralize up to 2 robbers. So they won't have an effect on your total, and you want to naturally return the maximum number of coins that you can get along your path, which can be negative if you just keep getting robbed by people, which is a bit of a shame. So if we look at an example, so 0, 1, minus, 0, 1, minus 1, 0, 1, 1 minus 2, 3, and then 2 minus 3, 4. So this is the coins matrix, and your starting point is over here, finishing point is down here. So looking at what is the best path you can take, going right or down. Well, for example, you could go like this, right? That's 7, 8 minus 1 gives 7. You go like that. You could go like that. 1 minus 1, 4, 8. Yeah, I think that was the answer anyway. Yeah, 8. So that's probably that one. You could go like across down like this. 3, 0, 4, right? 3 plus minus 3, 0 plus 4. So yeah, you go like that. Maybe like this one. Minus 1, 2, 6. So yeah, so you would kind of come up with the conclusion that's probably this one. 0. Is that the one? It wasn't this one, was it? 4. No, it wasn't this one. Oh, which one was it? Which one was the 8 one? Let me just read it. Move across to 0, 1. rows, then go down to 1, 1, then 1, 2. Oh, what's this? Wait, what? What does this add up to? 1 minus 1. Ah, but you neutralize. You neutralize. The neutralizing part is what makes it hard. Because otherwise, I think you could just apply the same DP, like... you could apply the same DP technique. You know what I mean? Like, I'm pretty sure you could just say, you know, okay, start with DP, like, imagine this is your base case. Like, what is the most number of coins you could achieve? 4, right? If you started here, the max you could achieve is 7. Here, the max you could achieve is 7, 6, right? If the neutralization wasn't a thing. But since it is a thing, then you could cut this one out and say the max you can achieve is 7 still, because you neutralize one rubber. And yeah, same with this, like what's the max you can achieve? Well, it's 4 because you neutralize this rubber, but otherwise it would be 1. If you start over here, it would be 6 if you neutralize the rubber, otherwise it would be 3 without the neutralization. So I think I want to say you want to create a kind of DP question. DP at a particular row, at a particular column is telling you, so this is a question that's asking what is max number of coins I can have if I start at RC and end at the bottom right. Maybe I have to give 3 answers, where answer 1 is if there was 0 neutralization, like if I don't neutralize anyone. Answer 2 is if I have 1 neutralization. Answer 2 is if I use all my neutralizations. Neutralize. So for example, over here, if I use 1 neutralize, if I use 0 neutralizers, then my max would be 6. If I use 1 neutralize, then my answer would be 7. And if I use 2 neutralizers, well, it's a bit redundant, but I would get 7 as well. So that's fair enough. And then how would I use this to like extend it? If I looked at this point here, my 3 answers would be 7, 7, 7, because there's like neutralization wouldn't do anything. If I looked over here, my 3 answers would be 4, 7, 7, because without any neutralizations, you could get 4. With 1 neutralization, you could get 7. Sorry, it wouldn't be 7. It would just be 4. Hang on, I did this wrong. With no neutralizations, you would have 1, because it'd be -3 plus 4. With 1 neutralization, you would get 4, because you'd neutralize the -3, and then with 2 neutralizations, you would also get 4. Fine. So if I look at like sort of this guy who has the choice to either go down or across, right? I would ask, okay, with 0, if I was to not neutralize, if I was to not apply neutralization here, then what is the best I could do? Well, I have a -2 plus I guess I could take the 2 neutralizations from here, right? Because I think this will definitely, like these 3 answers will always be in ascending order. Because a neutralization will always, it will never decrease your total. Always it will only ever keep it the same or increase it, because you're neutralizing negative values. So these 3 answers will be ascending. And the idea is, so if I say, yeah, what's the answer for this? If I have 0, if I don't neutralize at all, it'll be -2 plus, and then whatever's the bigger value from between these two. So either 4 or 7, so 7 gives me 5 for that answer. If I have one neutralization, I could either neutralize this guy, meaning 0 plus, and then taking 0 neutralizations from here and here. Wait. So if you're negative, then I either choose to neutralize you or I choose to not neutralize you. If I choose not to neutralize you, then I think I need to do all three. I think I need to have 0 neutralizations. So if I choose not so, okay. So to figure out the 0 neutralization, it would be the maximum between, the coins at RC plus, Q at R plus 1 C with 0 neutralizations, or coins at RC plus Q at RC plus 1 with 0 neutralizations. So for 0, to figure out 0, and then for 1 neutralization, I have 3 options really. If current coins, like at RC, is negative, then I have either I neutralize this or don't, right? So either I have 0 plus, so the max of 0 plus QR plus 1 C with 1 neutralization, or 0 plus Q R C plus 1 with 1 neutralization. So I can either not neutralize the guy I'm on. Actually, this shouldn't say 0. I can either not neutralize, in which case it will just be coins at RC and coins at RC, or I could neutralize, in which case this would be 0 plus, given that current coins is negative. So 0 plus Q of R plus 1 C with 0 neutralizations, and then 0 plus Q at R C plus 1 with 0 neutralization. So if I choose to neutralize this negative, then I have to choose the options where I don't neutralize when I go down or to the right. So that's if it's positive, then just choose the max between coins. It's really just this, where we don't choose to neutralize, we choose not to neutralize the coins because it's positive. QR plus, so you either choose to neutralize that one or that one. Now if there's 2 neutralizations, I think it's very similar to what we just did. Hang on. Oh my god, I hit a space bar by accident. So if there's two neutralizations, then check if it's negative. If current coins is negative, then you have the option to either neutralize this one or not neutralize this one. If current coins is negative, then either you don't neutralize, either you don't neutralize, so you get a negative value, and then you need to pick the two neutralizations here and here, or you do neutralize this one, in which case this should be 1 and 1. Otherwise, it's as if you did, you're not going to neutralize it because it's positive. And that should be enough to fill in all of the Qs, all the questions for all the positions. Calculate Q for all the positions. And then, that should be it. Okay. I hope this is kind of work. And then basically the final answer, we're going to return Q at 0, 0. And I think we can just say with two neutralizations. Because even if you only need one neutralization, the two neutralizations will carry that information across. It will just say, just pretend you did two neutralizations, even though you didn't actually. So, yeah. I think this is my final answer. Okay, let me try this. I don't know if I've thought of everything, but I hope I have. So, num rows equals length of coins, and then num cols equals length of coins at 0. I didn't really check constraints actually. Okay, that makes sense. So 500, because I'm going to go by n, so 500 by 500. Okay, so number of cols is that. Okay, so I need a DP array, which will be 0 for in range num cols, and then 4 in range num rows. So we have our DP array. And then dp at -1, -1, the very last thing, is just going to equal coins at -1, -1. And then if it's negative, then max of coins -1, -1 versus 0. And coins, because basically I'm saying that this is my base case, this is one of my base cases, this is my base case, right? So for the sake of asking the question, if it's positive, then my tuple here should be 4, 4, 4, right? 4, 4, 4. Because like with 0 neutralizations, what's the best you can do? 4. If with 1 neutralization, well, redundantly 4, because we're not going to actually use it. With 2 neutralizations, then 4, right? If it was a negative number though, if you had your matrix, if you had your coins matrix, but this value was -1, with 0 neutralizations, the best you can do is -1. With 1 neutralization, you could do 0, because you just would neutralize it, and then with 2 neutralizations, again 0. So that's what this is doing. Maximum between, if this guy is positive, then we'll use that value, otherwise we'll use 0. Okay, so we've got the base case. Now we just have to go backwards. So for thinking about, I'm going to go backwards through the rows, and I'm going to go backward to the columns. So for, I guess it's easier just to say for r in range, num rows -1 down to -1 with a decrement. For c in range, num cols -1 down to -1 by -1. If we're at the base case, if r is equal to num rows -1 and c is equal to num cols -1. We've already handled that base case, so just return, no, not return, continue. If r is equal to num cols -1, if we're on the bottommost row, then if coins at RC is negative, then zero neutralizations is equal to coins at RC plus dp, I don't... Actually, yeah, zero neutralizations is equal to coins at RC plus, so I'm only going across. I only have one option because I'm at the very last row. Plus dp, same row, but one column across with zero neutralizations. One neutralization equals the maximum between either I don't neutralize this one and I do neutralize the rest, or I do 0 plus this without any neutralizations. And then same thing, 2 neutralizations is equal to max between either I don't neutralize this one, in which case I do neutralize this one, or I do neutralize the negative, and I choose 1. Else, if it's not positive, then 0 neutralizations is the same. 1 neutralization is, I wouldn't neutralize this anyway, because it's not negative, so I don't actually need to do any max. 2 neutralizations is equal to, again, I wouldn't neutralize RC. Okay, that's fine. Just initialize these outside the scope so I can actually use them wherever I want. Right. If C is equal to num_cols minus 1. So if we're on the very last column, that means we can only go down. So it'll be very similar. Always a bit dodgy copying and pasting, but first we'll see if it works. So yeah, zero neutralizations, you just take the value and you look at the zero neutralizations value beneath. Otherwise, 1 neutralization, I think all that has to change is just this. Either, you choose not to neutralize and you do neutralize, or you choose to neutralize so you don't neutralize over here. 2 neutralizations, so it's same kind of vibes, but this is +1, and this is +1. So you have C plus 1, C plus 1, C plus 1, R plus 1, R plus 1, R plus 1. Else, so this is like the general case, this is where this thing happens. If coins at RC is less than 0, 0 neutralizations is the maximum between either you take this or you take this. 0 neutralizations across the board, either you pick going down 1 or going across 1. 1 neutralizations is equal to, well, it's basically option 1, or down option, is you go this way. One neutralization, right option, across option, is you go, wait, did I flip them around? This is the right option, sorry, because I'm going across the column. This is the down option. Going like this. Do I have to specify if... I don't think I have to actually do this. I think because, like, in the case where if this is positive, then this will always be bigger than this, won't it? So it will always pick the right answer anyway. So I don't actually have to differentiate between whether you're positive or negative. So just do that. I think the same thing applies here. So then one neutralization z is equal to the max between the two options. And then two neutralizations, the right option is equal to taking this guy, checking which one's better. Two neutralizations, the down option is equal to this one. And then so two neutralizations overall is equal to the max between these two options. Whoops. Okay, and then when you've done all that, then you should have safely set all these variables. So all I have to do is say dp at rc is equal to a tuple 0 neutralizations, 1 neutralizations, 2 neutralizations. And then I think if we safely iterate through all of that, then by returning dp002, we're saying using, at most 2 neutralizations, what is the best we can do? Oh, okay. We've handled the base case. Let's just see if it's any good. Whoops. Oh man, I tried to be really safe. Which part? There's so much indexing. Let me try print r equals r, c equals c, and we'll start there, I guess. I'm a little bit worried if it's like here, but we'll see. Maybe I should also print the num rows, num columns. So I expect num rows to be 2 and num columns to be 3. Okay, so I'm thinking this should be fine. This should be completely fine. Unless I initialize DPU wrong. This is a tuple of 3, right? Maybe I could yeah, let me try just make it all this just so that it looks correct. But that shouldn't be a problem because okay, good. Let me print what DP looks like at that point. Wait, we are in the else option. So that means it's not actually on one of those. Row 1, column 1. This shouldn't even be printing, right? Because it should be in the case. Oh, I said num cols. Whoops. Did it work? Did it actually work, or did I just get lucky for a couple of cases? That's the real question. Oh, man. Okay, wait. There were a couple of edge cases I said. So, for example, let's say you only have negative values. -1, -2, -3, -4, -4, -3, -2, -1, -10, -9, -8, -7. So like you expect the best value to be negative, and it's just about neutralizing the two worst guys. -6. So you probably neutralized like these two. Oh no, neutralizing think I trust it. I don't know, because I think the DP makes sense. Wait, what's the smallest case? A 1 by 1? This should give me 0 because it should neutralize it. I trust the base case, so this should work. Nice. And then if it's positive, then it should just give me the positive value. And then anything else? One row only, one column only. One column only. I should put some negatives in there actually. -7. -3. -4. So you should neutralize -4, -7 and leave it with the -3. -2. -12. So that should neutralize both of them. -1. I trust it. I think I respect the answer. It's not very well written, but I think it makes sense. Nice. Very good. Okay, I hope it made sense, because it's like, so yeah, I don't actually have to explicitly separate the cases between if it's negative, non-negative. The maximum will handle that for me. And yeah, so you just have to deal with the edge cases where, I don't know, they're not edge cases, but like the last row cases and the last column cases. But in general, you have two options. You either choose to neutralize this particular grid value, or you choose not to. And if you choose to take this one, if you choose to neutralize this one, then you can either choose to neutralize the other options, or choose not to neutralize the other options down the path. Which is why I think you want to carry all the information. Like, you want to carry the 0 neutralization option, you want to carry the 1 neutralization option, and you want to carry the 2 neutralization option. So then you can accurately reflect how many neutralizations you've done at that point and what value you achieve at that point doing that many neutralizations. So yeah, you're basically like not brute forcing, but you're essentially figuring out all the possibilities that you could do at any particular point. I just think it is written a bit weird, but yeah. What's this? Oh, wow. Yeah, so 3D, yeah. Similar plan, but wow. How did he avoid the? So you got M and N, you got your DP. Ah, you buffer it. Wait, but how come you didn't have to use the M in your DP dimension? Buffering is a good idea though. I think, cause like if I was to buffer this +1 and +1, and it was like 0, 0, 0 across the board, which I think is fair. I think I don't have to deal with the edge cases anymore. I don't have to deal with this. I think the natural. I think the 0, 0, 0s, the zeroed out. Oh, never mind. Does it not work? Ah, because yes, no, that makes sense. Because the base case, I've messed up the base case. It would be it should be num rows -1 num cols -1, which is coin. This is fine, and this is fine. This is fine because you're accessing coins. But the actual DP, you need to be very specific. Does this work now? Oh. Half works. I mean, I do make sure to scan. I zoomed in too much. I do make sure to start from num rows -1, decrement down to 0, num rows, num cols -1, decrement down to 0. I think there is a way you can make this work. It's just it's not how I initially wrote it, so it's like the code isn't quite ready for it. Num rows -1, num cols -1. I think it's just like the negative cases. It prefers to go. Yeah. Oh wait, what if instead of 0, 0, 0, I go like negative infinity 3 times? Wait, negative float. Because that way it would never prefer to go like outside the borders, right? Negative float, negative float, negative. Because that's why, like, it's using like these fake extra row and extra column I'm putting in to like access. It thinks that's like a better way of going, but it shouldn't. So if I do that and then I apply the base case, maybe this will work. It's a bit of trickery, but it's a bit cleaner in terms of the writing. A bit slower as well, but that's okay. I think I do prefer it purely because it's shorter. I don't know, actually. I don't know which one I prefer. It is like half a second slower. Interesting. So the buffering is a decent idea. N+1 instead of n. But I'm surprised that, yeah, how come your DP didn't have to have like a second dimension to it? For row in coins, for jx in enumerate row, so for each row, and then for each column in the row, you're not even going backwards. Maybe some people do that thing where if even though the robot's going from top left to bottom right, they kind of flip it and make it go from bottom right to top left. It's the same, like the computation is exactly the same, you're just flipping the directions. So like because I think this guy's comment. Oh, is this someone else? Can I get the older guy back? I liked his. There you go. Yeah, like this guy goes up and left instead of down and right. Like I think that's the idea. Oh, maybe not actually. DPJ+1. X up 0, up 1, up 2 is DP. Left 0, left 1, left. I'm assuming this is like up 0 is like with 0 neutralizations 1 and 2, so it's like the same idea. But how come? What? DP at 1 because that's like the instead of 0 because the 0 is like the buffered extra bit. DP at 1 is 0 3 times. I think my understanding is that you're somehow managing to figure out which is the best column to go through without actually putting it in the DP or something. Like you're able to do that. I don't know. It's a bit weird. I might read an explanation later, but this is interesting. And I guess it kind of reduces how much uh, space you use by a factor of n. Mm-mm-mm. Cool. All right. Well, not bad otherwise. Overall, good execution.